This is Pawan Kesara. I'm responsible for cloud services and digital transformation services in Fuji Technologies. A brief about me. I come from a core database and infrastructure background. So done a lot of migrations, managed services for large cloud engagements. That's more or less a brief about me. About my organization, Fuji is a digital transformation services company. We predominantly span across multiple products, which is product engineering, security, cloud, as well as quality engineering. These are our 4 areas. Within cloud, we have enterprise assessment services, enterprise advisory services, design and implementation, migration and managed services. That's pretty much about my company. Now diving into the topic, demystifying mainframe migrations. I'll take a pause here and share my screen, and then we can start off. Thank you. Please raise anyone a hand so that I know the screen is visible to you guys.
It is visible. You can go ahead.
Okay, fantastic. Okay. Thank you very much for joining this call. So today what we are going to talk about is how do we demystify mainframe migrations. There's a lot of angst and anxiety in the air when it comes to mainframe migrations, as opposed to other standard migrations what we do to cloud. Taking that into cue, let's start off looking at what we will cover within this migration webinar. So the agenda for this webinar is, let's do a touch base on what mainframes are, what does it contain, then art of possibilities of migrating mainframes, then the tools and softwares that are currently available in the market for automating the migration process of mainframes, common pitfalls within the migrations where the projects go for a toss. Security angle is very important area where it becomes paramount in importance when it comes to security of covering mainframe migrations. And the final one, what would be covering is measuring success. How do we measure the success of our migration of mainframes? So if you look at the evolution of mainframes at a high level can owe their origins to 1940s Harvard Mark I ENIAC machines, which are predominantly electromechanical devices, which are of a huge size. Their primary purpose was to use them in complex mathematical calculations. As with the advent of vacuum tubes as well as punching technology, the first fully formed mainframe, we can call it as IBM 700s, have been released. They were more running on vacuum tubes, and previously the input was a punching cards with the punches in it, which the mainframe would read out and perform the tasks that are assigned to it. As we move forward, when it comes to 1960s, then the transistors came into play, and the initial stages of transistors, IBM never had any, mainframes never had any of its own operating system. People are expected to develop their own operating system, but they were provided with Fortran compilers, COBOL compilers to perform the tasks the systems were intended to use. From there, as we moved to 1970s, the integrated circuits had started coming. Before we go there, in mid of 1960s, IBM realized that maintaining hardware on different operating systems would be tough because everyone was developing their own operating system to use this. So they came up with S360, which predominantly had programs like MVT, MFT, and this thing. MVT stands for multiprocessing variable transactions. MFT stands for multiprocessing fixed transactions. Predominantly, this is to control the RAM space, how the program would be using. As we move forward in 1970s, we started seeing transistors. 1970s started seeing the integrated circuits. So IBM further developed 370s on that. Then when it comes to 1980s, it's more of a microprocessors. And when it comes to 90s, it is predominantly the major shift in paradigm is now IBM mainframe started handling 64-bit architecture in their systems. From then on, it moved graduated to ZOS, which become more like a open mainframe. Before, IBM was not a closed system; it didn't had any open operating systems. ZOS, Z frameworks enabled IBM to get into the open Linux and Linux variant platforms onto the mainframes. Moving to next slide. At a high level, if you look at it, what does IBM mainframe contain? It contains batch processing, online transaction processing, then information management service, which is in two formats. One is called vSAMs, which is file-based. You can call it as databases. Then relational databases like DB2, IMS kind of stuff. These are supported. I mean, from a programming languages perspective, like COBOL used to be the main language, Fortran more for a scientific one. JCL is used for scheduling the jobs. Job control language is called JCL, Rex, etc. These are supported by schedulers, print and sort, code versioning, and all these things were running on ZOS in the latest format. Previously, it was OS 360, OS 370, and in the latest formats, from 1990s onwards, you started seeing the virtualization of the mainframes, where they are called as LPAR. They are hardware partitioned, and you can have multiple virtual machines running on the same hardware, which now we will see in the all the cloud environments. So now, what is that we need to look at when you are doing the migrations? So one of the things that becomes all the more important is how do you migrate these things, and what is the target platform when you are migrating mainframes? So operating system, MBAT, MBS, they can be migrated to Windows, Linux, or Unix. Kicks, which is basically the online on-demand transaction processing. Those can go into Micro Focus application server. Oracle has Tuxedo, GST software, Fujitsu. Databases, Micro Focus, Oracle database. Assemblers, you have COBOL, CHash, are mapped to OS functions. JCL, PowerShell. JCL can be replaced with PowerShell, and there are many tools like Control S and others which can also take over those things. So like that, if you look at it, you pretty much has an equivalent target from where mainframes legacy applications can be migrated to. A sample of this was put up together. This is just a representative purpose. Programming language, if you have to refactor it or reimagine it, then it can always go into Java. Databases, Oracle, batch can go into Spring Batch, XML. User interface screens to JSF, HML, HTML, and CSS. Like that, encryption we can have. They have mega encryption that can go into Java cryptography architecture. So Grit, Jenkins, Puppet can be used for the deployment. So there are many options for legacy mainframe applications that can be migrated or rehosted as is or refactored. So let's take a quick look at various reference architectures leading cloud service providers are professing. If you look at AWS, what AWS is professing is basically two ways. Either you can rehost the application completely using either AWS Fargate, which is basically Docker images, or the Lambda functions, function as a service, or Amazon ECS, which is basically the virtual machines of Amazon. From a storage perspective, there is a from a database perspective, you have Amazon RDS, Amazon Aurora. Then from a backups and storage perspective, you have Amazon S3, Elastic Cache. From an analytics perspective, which is more of going beyond complete lift and shift or rehosting, you have various services that can be used, like for example AWS Glue, Amazon Athena, EMR, Redshift, QuickSight. So these are all the tools that can be leveraged to get more insights into the data, or even automating the process, reducing the time to market capabilities. While this is of AWS, it's interesting to see even Oracle has a cloud reference architecture for mainframes. Oracle heavily relies on their leading platform, Tuxedo ART, where they profess or they recommend using Tuxedo for hosting the cakes batch programs and others, while the database, they always talk about Exadata systems. Exadata is an engineered system, highly powerful, and it has a direct access to the server storage, which helps them to increase the TPMs, transactions per minutes, almost 10x more than a standard logical machines, what you see in the general world. Now, the third one, what we are going to talk about is Azure. In Azure, they talk about Azure provides emulators which help customer to run the migrated mainframe workloads as is without even changing anything. And they propose databases for Azure SQL Server, MySQL, a lot of things. And these are all supported by Azure AD Security, Azure Access Control, to put the security controls on the system. Now let's look at the way, what options customers have when they are migrating. I mean, these are a lot of questions a customer has to go through or think through before he start the journey of to cloud. So whenever you are migrating from mainframe, like any other application migration methodology, here also you will see a lot of options that customers can choose from depending upon their objective. So if you look at it, one of the things is region extension. Region extension is nothing but you pretty much lift the IBM hardware or mainframe hardware and put it into the cloud region, where every cloud will have a region extension. I mean, almost a majority of the cloud service providers have a region extension where you can host your hardware that can be very close to your system, thereby avoiding latency and as well as bandwidth issues. Now, what does it achieve? I mean, what is the purpose it will serve? So if a customer has to exit from their data center, they have a contractual obligation, and mainframe is the only thing which they are not sure about. So in such scenarios, what customers can do is they can always buy a region extension or the data center space where you can forklift the mainframe applications and put it, and while other applications are hosted in the cloud. The objective of this one is you are not touching anything in mainframe. It is coming as is, and you will not see any challenges of migration or side impact of migrations due to this process. However, this is not going to help you in any way leveraging the cloud capabilities. In order to leverage the cloud capabilities, the next logical step is basically one of the main capabilities of cloud is reducing the cost of operations and reducing the cost of hardware. This can be achieved either using rehost or replatform. As we spoke in Oracle Cloud and as well as AWS, there are many platforms. Even in Azure, they have mainframe emulators to which this application can be migrated without even touching the code. So functionality remains same, technology is standardized, and the database piece can be migrated into standard Oracle standard database workloads, be it SQL Server or MySQL, depending upon the transaction transaction requirements, transaction performance requirements that would be needed there. So here, if you look at it, the application logic, the business logic remains same. It is only the database which is migrating, and so the risk of something breaking would be very minimal in these areas. However, you are still not able to leverage. You are only leveraging the cost factor of the cloud, but you're not able to take advantage of agility as well as velocity of the application transformation that you can enable using the cloud. Now, coming back to the refactor and leveraging, here there is a scope for consolidating the applications, rationalizing the applications, then also leveraging cloud native applications. You can modernize your database depending upon the versions what you are running on. The last one is reimagining. This is a complete end goal of any customer, ideal goal for any customer, where they can migrate the complete applications as well as leverage the velocity as well as the economics of the cloud. Moving to the next slide. Now, how do we do these migrations? So typically a migration should have challenges identified that have to be handled. And number two, then you need to assess your application footprint. When I say application footprint, there are a lot of things that you need to factor in. What are the integrations? What limitations each of these applications has? How they are interrelated? All these things will come into play. Now, coming back to the when it comes to the assessment, it can be two ways. One is logical assessment and the other one is technical assessment. Logical assessment more talks about business logic, how each one is correlated or interrelated. Technical assessment predominantly talks about from a servers where it is accessing, what ports it is working, kind of stuff. Then you do a cost benefit analysis against various options what you have in hand. What is that you are going to gain from this thing? All these together will help you define your cloud roadmap or digital roadmap. Now, once you define that one, you can go with a combination of various things depending upon the application criticality. Maybe few applications are not even worth migrating that effort. Then you may want to look at region extension. Those applications will remain in the mainframe till they die a natural death. Then there are some applications which you know that they would be there around for some time, but the functionality wise they are perfectly fine and you don't need to do that. You don't need to do anything. Those applications you can look at for rehosting. So many of the customers, what they could able to achieve is basically they migrated the databases, thereby able to leverage the data that had been accumulated over a period of time to use cloud native tools to monetize the data that had been there and build insights into that. Now, refactor and renew will come into play when your business logic needs to be upgraded and business users or business owners are looking for something new features that can help them better their processes or improve their business. So this is where refactoring and renew will come into picture. And reimagine is a complete reimagination of the application, what can be replaced, what can be terminated, all these things will come into play. So these are the various phases. Depending upon the application what you're choosing, those things should be planned for. Coming back to from a mainframe application and migrations, from the olden days till date, there are many migration softwares that had come into picture, migration softwares and modernization softwares. The list what I had put up here is a representative list. So it's basically, if you look at it, Advanced is one company which had done almost 500 plus mainframe migrations, their website claims. They have a complete end-to-end, right from analyzers to the application transparent platform for rehosting. Then they have refactoring capabilities, automated capabilities, tool-based ones. So this is one thing where they provide both tool and services, and they have their platform is certified across leading clouds. Asynco is one more thing. Blue Age was an independent till recently. AWS had acquired it. Now you don't see Blue Age certified across all the other clouds. Google of late had defined their own tooling and as well as cloud native services. So Google is also a good option for migrating. While AWS is far ahead on the migration game, Google is also coming up, so is Azure. Micro Focus has an in-depth knowledge of my mainframe modernization. They have a fantastic platform which can do both refactoring, analyzing, and code. And they are certified across AWS, Google, and Microsoft. So you see most of these services, their services being co-sold by these leading platforms. Now, apart from this, there are many other tools what you will see in the market which can do right from analysis to mapping to refactoring to automation in an automated way, and few of them have few limitations. So Blue Age, as we spoke, like is very good at refactoring. Micro Focus has end-to-end capabilities of application migration, rehosting, and replatforming. Visual COBOL, OpenFrame, COBOL to Java transformation is what it is good at. Software AG can do a good job in legacy modernization API enablement. So there are many tools based on our requirement and our application analysis. We can choose the tools that would be right suited to do the job. Now, coming to common pitfalls in any mainframe migration, predominantly what you would see is these 10 things what you should be very careful about. One, always we see that when you don't do your analysis fully, there is a very great chance that you might be missing the interdependencies, the architectures, because one should remember that the main application code in mainframes had been evolved over a period of time. When I say period of time, it is over decades. It's very important to completely analyze, fully understand what we are getting into, what challenges would be there, thereby avoid scope creep and as well as complexity creep, thereby avoiding the migration effort. So predominantly what happens is when you didn't do a good analysis and complete scoping of this one, there is a high probability that you will have budget overruns, project delays, and technical challenges because you have not foreseen them coming in. Apart from that, the other one important thing is most of the customers where they are the partners, where they fail is lack of comprehensive planning. When I say planning, it's not about standard migration waves. You need to understand the how do we manage the change management? How do we manage the cultural shift? How do we set the goals for this one? Who will be the blockers? Who will be the enablers? Who are the stallers? All those things we need to do a thorough analysis when we are doing this plan. And testing is the most important thing where many migration projects tend to fail because of lack of testing during the uh, pilot runs. So it's very tough to fix issues when you're already on production. Rather, you identify them, catch them ahead of time, and fix those things is the best way of doing this. And given that there are so many automated testing tools that are in the market, this should be something that should take full leverage of the testing capabilities. The other thing is data migration challenges. As we spoke, like mainframes has vsam files, we have a database. So it's very important that when you are migrating the data, you will not lose the referential integrity of the data, also security of the data. And if you don't plan your migration properly, data migration properly, you might end up losing the data, or you would see missed links in this thing. So it is very important you have a solid migration plan, data migration plan in place before even moving forward. Lack of skill set is basically we are talking about if when you're choosing your partner, you should do a thorough due diligence of their capabilities, both on the mainframe and as well as the technologies, target technologies where you're working. The other important thing what you need to understand is, be it cloud or on-prem or anywhere, it is always advisable to avoid vendor lock-in. So how easy it is to move away from the vendor is something what you should always look for, because changing priorities, changing uh, roadmaps can always force you to move away from the technologies what you have chosen today to other technologies. So vendor lock-in is one of the uh, pertinent problem many customers are facing today. That is should be avoided at any cost. So from a security concerns perspective, mainframes are very famous for their tight security and failing to address security consideration. When I say security consideration, even though you are doing rehosting, things like compliance requirements, things like uh, authentication methods or access control methods might vary. So it is very important to understand the complete gambit of security that is required and plan and design the security accordingly. And whenever you are doing migration or modernization, predominantly when you do refactoring or reimagining, people do tend to miss the business logic, thereby completely having a broken application in place. So it is very important to understand the business logic and ensure that the business logic is properly transformed into the target environment. Change management, when I say change management, it is not only about the regular change management, it is about user habits. Most of the customers who are working on uh, customer teams who are working on mainframes, they are more used to the keyboard rather than the mouse related kind of stuff. So sometimes even the screen change might have a greater amount of discomfort for the users, and they might resist changes to this one, which creates confusions and reduce the decreased productivity. So it is very important to start involving them from the beginning, uh, setting the expectation, guiding them through the process of change management, and ensuring that they are comfortable with the new look and feels, and their productivity is not getting impacted of the new look and feel kind of stuff. Performance optimization is the most important thing, because many a times mainframe applications are more known for their performance capabilities. When you are migrating to cloud environments, it is very important to ensure that the performance is rather improved rather than degraded. So it is very important to do the stress testing, benchmarking testing, as well as uh, specific application critical process testing is very important, and recording the complete performance as well as combination of testings to ensure that the performance is optimum for the migration to be successful. And last but not the least, the there are there should not be any cutting corners when you are doing the migrations, because wherever you cut the corner, you would end up paying multiple times once you move to production, because the changes and other things would be very tough to do when you are already in the production. Coming to security, we spoke about security in great deal in our last slide. So what is security? Like, I mean, why do we should we be worried about security? Because we are migrating mainframes and it is no different from other applications. So the biggest challenge what you will see is when you are migrating the data, you should ensure, like, I mean, many of the other applications you will not see very strictly implemented data at rest and data in transit. So whereas mainframes comes with that inbuilt capability of data encryption at data at rest and data at transit, it is important that you maintain the same thing when you're migrating to the cloud, so that the application security is intact. When you are migrating mainframes, the way of access control and authentication is different when it comes to cloud. So it is important to understand what kind of authentication and access control they have, and whether it would have any impact on the choice of tools or choice of applications we are making. And the best thing is to implement a multi-factor authentication, as well as identity and access management practices, to ensure that the application is cannot be accessed by unauthorized users. Network security, while mainframes have a different security architecture like TSAM and others, we need to draw parallels to how we can ensure that there is a zero trust policy is something what we should implement, predominantly while implementing firewalls, introduction, IDS, IPS systems, and when you're segmenting the networks and ensuring the data flow is restricted at every level. So same is with the application security. With the advent of internet and other weaknesses, it is very important that we identify the security gaps in the code as well as input validation issues that could lead to security breaches. Audit and logging is the norm of the day if you want to address the security breaches on time. So this is something that we should bring in immediately. Compliance and regulatory. So many of the times, like when if you look at FedRAMP or some of them are there are geo restrictions. So those are the things what you should also factor in, how your compliance get impacted by moving your hardware from location A to location B. Would it have any impact? So those controls has to be revisited and looked at, and if required, redefined those controls to ensure that they are compliant with the cloud. While data migration is happening, it is always recommended to ensure that the data migration happens over the encrypted data transfer mediums. And OSs as well as the applications are more prone to these security holes. So it's important to establish a cadence for patching for security vulnerabilities, uh, right from the OS level all the way till application and tech stack components. A SIM is very important to be implemented. It is very important because the habits and methods of handling activities in mainframe might be different. When it comes to cloud, it is more prone to the security risks. So teams should be trained as well as made them aware about potential security threats. What can they do to help prevent any accidental security breaches due to a human error? And the third party integrations is the most important. Whenever there are APIs that are coming into picture, it becomes all the more important to ensure that you have a two-factor authentication implemented. You have access control. You have API usage controls implemented, so that it becomes next to impossible for potential hackers to get into this. Basic authentication is a absolute no-no when it comes to third-party integrations. It should be always it should be always like a security-based authentication that should be in place. So now all this is great, but how do we know whether my migration is successful or not? How do I measure that? So one of the things is a migration is not considered, a mainframe migration is not considered as successful unless you have defined your KPIs. And following are the list of KPIs, what we have defined, what had been defined over a period of time. So if you look at the KPIs from a business goals perspective, so one of the KPI that you should definitely measure is whether the migration is aligned with the overall, did it achieve the overall business objectives? Are we, for example, are we achieving increased agility? That is the objective what we had. Did we have a improvement in cost savings? Or do we measure, have we measured customer experience? Is it better or is it worse than what they were having before? And the next one is basically cost savings is the most important factor, KPI, that has to be measured whenever you are migrating to cloud, because the premise of migrating cloud is both from capex and opex perspective savings. Whatever you have planned or whatever you have projected or forecasted before the migration, to what extent have they achieved? Have we achieved beyond the projections, or are we falling short of it? this is another KPI that has to be measured, which is very important in these scenarios like this. Then when it comes to uptime, reliability, and uptime, there are many ways of measuring this. Predominantly, I mean, in the new age world, I mean, site reliability engineering has a list of parameters that you need to be uh, looking at from a reliability perspective, rather than a simple uptime of the environment. Like what are the critical functions, what is the expected uptime, reliability, how will you ensure that the services are reliable, it is not having any performance issues, kind of stuff. Cloud, one of the main advantage of cloud is about ability to scale and ability to uh, adapt to other service offerings quickly. So those are the things that is one more interesting KPI that can be measured. So real user feedback, real user monitoring, real end user monitoring is another way you can always monitor user experience. Then how well the change has been adapted, is the complete team or end users aligned to this change? Are there still any gaps in the alignment? So that is another way of measuring it. Did it improve faster time to market? I mean, like, have our development cycles improved from what they had before and to what we have today? Operational efficiencies, predominantly, like, uh, how much of reduction had brought in, like from an operations perspective, from an operational efforts, from a manual process reduction perspective, how much of reduction had happened is another KPI. Security and compliance, how much has been improved from the source, which is mainframe. Um, and always a survey is very important to look at how user adoption has been progressing and whether users are satisfied with the new changes and are they comfortable with this thing. Downtime and disruptions is nothing but uptime and reliability, inverse of that. So sometimes customers believe downtime and disruptions is a better KPI to measure than uptime and reliability. Then timelines wise, whether migration, have we missed any complexities? That is what has to be is another KPI that can be measured. And providing vendor support and relationship, like level of support received from vendors who are helping you in the migration, is another area that can always be measured. All these measurements would only help you to get a right picture of your migration and help you to come up with what additional changes you have to do. By measuring these throughout the migration phases, it helps you improve and make the migration as smooth as possible. So that's pretty much what we have today from the mainframe migrations. Thank you very much for joining this call. If you have any questions, or if you wish to have learn more about mainframe migrations, please feel free to reach us out. I'll be more than happy to conduct few more webinar sessions, which might be deep dive into various migration factors and migration approaches. And thank you all. Thank you very much.